Howdy, math neighbors. It's your boy coming back at you with another AP Calculus video. You know you like this. Make sure you have liked and subscribed. Smash those buttons. Pause the video right now. Go do that. We are going to take a look at some more integration by parts here. And I have 5 wonderful, delightful examples prepared for you. Some of these you may have seen before. Some of them I may have gone over in class, but I'm recording them so that they exist in perpetuity. So you know how I like to do math. I like to show you the whole thing and then go through it. So remember, you have the power to pause. Pause. I suggest you try this one on your own and then be ready to check and go through it. You're going to get a lot more out of it that way. But here's what the final answer looks like. Again, take advantage of pausing. And let's talk. How do we do this sucker? So we don't want to necessarily set out with the goal of doing integration by parts. Now, you know you're doing this because I told you that's what this video is about. And we still want to train ourselves to be prepared for those circumstances where we don't know what we're doing. Are we using substitution? Is it on this list? Is it something else? Is it something else? What's it going to be? How do I know? Those are the types of skills you want to build, because when you're doing questions for real, like on your own, no help, no handles, no substitute, no ladder, none of that. It's just you in a math problem. How do you know what to do? Those are the skills you want to be trying to build by doing the practice. So I'm going to try to model for you my progression. So my progression is I look at x e to the x. I say it's not on the list. I think about all of the different ways I could rewrite it using algebra. Like, for example, I could say x divided by e to the power of negative x. That doesn't really help me. I could try a bunch of stuff. I could just say e to the x times x dx. Doesn't help me. So those algebra pieces, that can take a long time to figure out if it's going to work or not. And I thought about substitution here, but none of that really seems to help. So I went on to doing integration by parts. And when you're doing integration by parts, especially when you're a beginner, which you still are probably if you're watching this video, kind of what you're struggling with is looking at the formula. Okay, I have u dv. Does u equal x or e to the x? Does dv equal x dx, or does dv equal e to the x dx? Which is it? How do I know? And the general thing is, going back to the chess analogy, think a few moves ahead. If I choose u for x, I'm taking the derivative of u, I get dx. If I choose u for e to the x, I get e to the x dx for the derivative. If I take the antiderivative of x dx, I get 1/2 x squared. If I take the antiderivative of e to the x, I get e to the x. So you look at all of these, write them out if you have to, like I did here, and think to yourself, which of these actually makes this more simplified? And u being x turns into du dx, and dv being e to the x turning into e to the x seems like it's simplified. So if I go to my formula, well, I'm not going to go to my formula yet, sorry. Forgot how I did this problem, or the order I did this problem in. So, reminder, when we think about integration by parts, after we choose u, we differentiate to get du. After we choose dv, we anti-differentiate to get v. So derivative of u equals x is du equals dx. Antiderivative dv equals e to the x dx is v equals e to the x. So the formula is u dv minus v uv, or equals uv minus v du. Putting all of the things in their spots looks like this. And this is where we arrive at what's going to be a crucial step or consideration moving forwards. I have u times v, x times e to the x, minus the antiderivative of e to the x dx. I can do an antiderivative of e to the x dx. That's on my list. It is e to the x. That means that we are done with integration by parts here after one usage. If you were to take the derivative of x e to the x minus e to the x plus c, you would get x e to the x. Here's the next one. Again, pause the video, try it. Even if you've seen it before, it's worth it. Here's the final answer. Again, pause the video, check over your work. Here was my thinking to go with this. So I looked at this and I again went through the same progression. I said, okay, what's on my list? Not this. I thought about rewriting it. How could I rewrite it? I could use exponents, making positive exponents negative exponents. There's not really anything to factor. There's not really anything to distribute. There's not really a lot of algebra to do here. I thought about substitution. If u equals the natural log of x, du is 1 over x dx. It doesn't help me because I have x squared dx. What am I going to do? None of those. It's a product. Let's try parts. And when you're trying parts, again, you choose one of those parts, either x squared or the natural log of x, to be u, and the other one is going to be dv. So dv is either x squared dx or the natural log of x dx. So you think to yourself, when I choose u, I take the derivative. When I choose dv, I take the antiderivative. So if I look at this, what's the derivative of x squared? 2x. Okay, that seems pretty good. What's the derivative of natural log of x? 1 over x. That seems pretty good. How about antiderivatives? Antiderivative of x squared, 1/3 x cubed. Doesn't really seem simplified, but the antiderivative of natural log of x, I can't do that one. That is not on the list. That's how I figured out that I would choose u as the natural log of x and dv as x squared dx. Again, taking the derivative with respect to x of u equals natural log of x. On the left side, we get du dx. We multiply both sides by dx. On the right side, we have 1 over x dx. When we do an antiderivative of x squared dx, we get 1/3 x cubed, add 1 to the exponent, multiply by the reciprocal. Substituting into the formula looks like this. U is the natural log of x, dv is x squared dx. You don't have to change the order. I was feeling thorough, so I changed the order. Then I have u natural log of x times v 1/3 x cubed minus antiderivative of v du. V is 1/3 x cubed, du is 1 over x dx, which, looking at the antiderivative, 1/3 x cubed times 1 over x, I can't do that. That's not an antiderivative that's on my list. But if I remember that I am allowed to multiply 1/3 x cubed by 1 over x, I get 1/3 x squared, which is definitely on the list. That's 1/3 times the power function x squared, which is where the final answer comes from. uv 1/3 x cubed natural log of x. I just changed the order there because usually we will do the polynomial before the natural log, minus 1/9, that's 1/3 times 1/3 x cubed plus c. Here comes the next one. This one is beefy. So, same suggestion. Here's the problem. Pause the video, try it. You're going to be trying it for a while because, again, this is a beefy one. Here's the final answer. Yep, that's a beefy final answer. Pause the video here, check over your work. Now I'm going to go through it. So when I start, same considerations. I think about, is this on my list? No. Can I rewrite this? Yes. Does rewriting this help me? No. Does rewriting this help me do substitution? No. It's a product. Integration by parts. Let's find out. What do I do for integration by parts? Well, I say if u is x cubed or sine of x, what happens when I differentiate? If dv is x cubed dx or sine of x dx, what happens when I anti-differentiate? That's going to tell me. But the problem is when I do that, so I chose u is x cubed and dv is sine of x dx, I don't really get anything simplified here. I have uv x cubed times negative cosine of x minus the antiderivative of negative cosine of x times 3x squared dx, which is a problem because that's an antiderivative that's not on my list. It's an antiderivative which are similar to the first one, right? E to the x dx, that's on my list, got it. Previous one was not on my list, but I could simplify it using algebra. This one, I can't. So what does that mean? Well, substitution doesn't work either. I do parts again, but only on this antiderivative. So it's the same consideration. Should u be 3x squared dx, or 3x squared, or should dv be 3x squared dx? Which one? Well, I know it didn't simplify completely, but it sure helped a little bit going from x cubed to 3x squared. So we continue with that. Here's a hint, an inside math hint. When you're doing parts repeatedly, you want to continue taking the derivative of the same thing. So if you had u being x cubed, you want to have u be 3x squared, the polynomial function again. So 6x dx, dv is cosine of x dx. The function whose derivative is cosine of x is sine of x. And I go back to what I had, but now I've replaced this antiderivative with parts again, uv minus v du, which is another oh dear. We have to do parts again. How did I know that? The same way I knew to use parts the first 2 times. I went through my progression. I thought about it. Okay, so doing parts again, the inside math tip, if u was the polynomial function, u is the polynomial function again. Continue to take that derivative. dv is the trig function. The function whose derivative is sine of x is negative cosine of x, because the derivative of cosine of x is negative sine of x. Substituting again, it's just getting messier and messier to work with, but I've replaced only sine of x times 6x dx. So that's now uv negative 6x cosine of x, because cosine is negative, minus the antiderivative of negative cosine of x times 6 dx. This is finally an antiderivative I can do. So I distributed all of my negative signs to make sure everything was going to be good. So I've got a positive term, a positive term, a positive term, and then a negative, 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 negative term. Antiderivative of 6 cosine of x dx is 6 sine of x. Beefy, like I said. 2 more. One of them beefy. The other one not so beefy. Here is the next one. Again, pause the video, try it. Here is the final answer for the next one. Again, pause the video, check your work. This is me going through it. So I look here, I do the same considerations I've done before. The problem is I don't have a function to declare as dv unless I get sneaky. There's nothing that says dv can't be just 1 dx or dx. Hey, you learned something. Nice. So substituting into the formula, we have the natural log of x dx equals the natural log of x times x minus antiderivative of x times 1 over x, which is again not on our list, but can be simplified into one which is on our list. So we have x times the natural log of x minus x, which is the antiderivative of 1 dx plus c. Nifty. That's how you do the antiderivative of natural log of x. Cool. Here is the next one. Again, pause the video, try it. Here is the final answer for this, the last one we're doing. Again, pause the video, check over your work. This is me doing this one. So same progression, I won't repeat it, but u is going to be arcsine of x. This is why you need to know ice cold, those derivative and antiderivative shortcuts. When was the last time you thought about the derivative of arcsine of x? Not recently. Didn't use the chain rule, so that was nice. So I've got 1 over the square root of 1 minus x squared. V is x because dv is dx. Going into the formula now, uv arcsine of x times x. V du, x times 1 divided by the square root of 1 minus x squared. Now, something that I like notationally speaking here is I like doing big brackets around the whole stinking thing and then writing in my limits of integration. That's what I like to do. You don't have to do it that way, but I like doing it that way because it helps remind me that I need to substitute into arcsine of x times x. Okay, continuing. We look right here and we think to ourselves, how that stinks. I can't do that antiderivative. It's not on the list. Oh, wait, but substitution works. Now, in case you're curious, the reason why I did not change the limits of integration here is because I did the substitution inside these limits of integration. So I didn't feel like I needed to change them. But u is 1 minus x squared. I did that with the intent of getting 1 divided by the square root of u. Du is negative 2x dx, so to substitute for x dx, I can substitute a negative 1/2 du, which I did. So I have x arcsine of x minus the negative 1/2 antiderivative u to the negative 1/2 du. Antiderivative of u to the negative 1/2 is used to the positive 1/2 times 2. Substituting x back in for u, 1 minus x squared. Simplifying 1/2 times 2 and the double negative gives me this. This is my antiderivative. Now I need to, because it's a definite integral, employ the fundamental theorem of calculus. I'll evaluate this at 1, evaluate this at 0, subtract the results. Evaluating at 1 yields 1 times arcsine of 1 plus 1 minus 1 is 0. Evaluating this at 0 is 0 times arcsine of 0 plus square root of 1. Arcsine of 1 is pi over 2. Arcsine of 0 is 0, even though it doesn't matter. So I have pi over 2 minus 1, which is that value rounded to 3 decimal places, which is the same thing as what I got if I type this into my graphing calculator. Looks like that. So again, if you enjoy the content, which I know you do, make sure you are subscribed to the channel, and I'll see you in the next video. Peace.